everybody, and welcome to another episode of Function Junction. I'm Simon Timms.
And I'm Eric Fleming.
And we have not recorded in a really long time.
Many months.
Because, I don't know, we got to come up with an excuse. I was in a horrible disfiguring car crash, and it's taken me this long to regrow my face.
It shows.
Yeah.
I mean, no, it doesn't.
I mean, it's like a second-rate face now. I had to go to the discount face bin. Anyway, we wanted to talk about durable functions. So in theory, this is going to be one of a couple of episodes in which we go through durable functions in some depth and detail. This is going to be our introductory one, and we're aiming for it to be not too long. We'll see if we succeed in doing it. Okay, so Azure Functions. That's the space that we're in right now. And we typically, when we run an Azure function, it is something that is short-lived. Like that's the ideal thing that you want to do with it. Like send an email, render a picture, publish a report, something that is pretty quick and simple to run. And this is because that's kind of the way the thing is structured, and also the pricing model and the structure of everything is that if your function takes longer than a certain amount of time to run, it starts becoming really expensive, and if it takes longer than, I want to say 5 minutes, but I feel like it's been relaxed a little bit now, then it's just going to be killed, depending on the hosting model that you're using, of course. So I'm almost always going to be talking about the consumption hosting model, because I think that that's the way to go. So just asterisk that in your guys' minds as we go through this. So this has been the typical approach for functions, but there's a lot of scenarios that don't fit well into that, and one of the big things around that is any sort of like business workflow that you have. So you want to like send emails to 6 different people and wait for responses and do this and that and the other thing. I mean, these are typical sorts of things that you would do as a business, but they don't lend themselves to kind of single interactions, and that's where durable functions come in. So durable functions are basically a really nice and simple way to build out orchestration between a bunch of other functions. And by that I mean that you have kind of a master function that spins off some other functions and waits for them to come back, or waits for some condition to be met, and then continues executing. So a lot of people would call this a saga pattern, depending on who you are. Whether that's right or not, you might also know it as a process manager. But in function world, it's going to be called a durable function. Okay, so what sort of problems can we solve with this? So the documentation gives us some really nice examples here, and some really swish-looking pictures here. So one of the things you can do is function chaining. So that means you have a function that executes, you wait for it to complete, and then you want to execute another function at the end of it. And maybe there are some decisions to be made in between each function execution, or maybe you just want to have checkpoints at some point in your functions. You want to go and run function 1 and then save everything, and then run function 2 and save everything. So that's function chaining. That's right here. The next one is fanning out. So this is a great one to do. So this is also known as scatter gather. So you're going to kick off some function, it's going to spin up a bunch of other functions, wait for those to return, and then do something with that. So a great example of this might be something like you want to process a batch of images or something like that. So you spin up a single function, and that single function goes and figures out what the batch looks like. So maybe it retrieves it from the database by ID, and then it generates a bunch of calls out to other functions which are going to go and do the actual processing, and we're going to fan those out. So those are going to execute on 10 machines, 100 machines, 1,000 machines, something like that. You don't really know behind the scenes in the consumption model what you're running on. I mean, you can find out, but in general, you don't care as long as it gets done. And then when all of those have reported complete, they're going to feed back into that first function and say, yeah, I'm complete. So I mean, these are both patterns that you could do without durable functions, and all of this stuff in durable functions is stuff that you can do with Azure Functions without the durable stuff on top, but it's way easier with the durable stuff on top of it.
Yep.
There's some asynchronous stuff that you can do here. So if you have a fairly long running orchestration, you can kick that off and it will give you back a status URL that you can then query from some other process and see, hey, is this done? Is this done yet? So that's a really nice thing to be able to do, to be able to launch something and then poll for it. Even nicer is to hook this into the Signal R service that's been released fairly recently and publish messages through Signal R instead of through this. And then those are kind of like the big ones that I was thinking about talking about. This human interaction one is something you could do too, where you're kicking up a function and then you're expecting some sort of human interaction with it. So somebody checks something off to say, yes, this is good to go. And then it'll go off and do something with that. So those are the ideas behind durable functions. And so if you're familiar with something like in-service bus, you'll have seen sagas, which are, again, very similar to this, but the approach is a little bit different from durable functions and sagas, how they work. Well, durable functions are interesting in that they have a single entry point, which is known as the orchestrator. And every time something changes or completes inside the function, it's going to run that orchestration again. So if you have something in orchestration like logging, for instance, then you go off and you do this function chaining thing. That initial log message that you have inside of your function, say you have a log message right here, you're actually going to see that hit 1, 2, 3, 4 times, because every time something changes, we go in and we run this function again. And the real secret sauce here is this context, this durable orchestration context, and calling an activity async. So calling an activity async means that you are going to launch another function that's defined inside of your application that's going to go and do something. And then you're waiting within a wait for it to be complete. So this looks like just standard C# code, and it is standard C# code. The way this works behind the scenes is that on the first entry into this function, so in F1, we come in here and we run this little piece of code here, and then we basically return for the rest of the function. So we skip the rest of this stuff here until that function completes. And then the context knows that function 1 has completed. So it re-enters into this here, and we hit this first function call again. So the durable function knows that it has already run this F1. So it's not going to run it again. So it just basically returns from that immediately, and it'll call this next one, and so on and so forth each time through. So this thing gets re-entered a bunch of times here. So there are a couple of limitations that you have to be aware of around here, in that if you're going to do anything asynchronously inside of this function that isn't like awaiting the context, then stuff gets crazy and weird. Basically, this has to run on a single thread inside of here. Otherwise, stuff messes up pretty seriously. And there is actually some detection within the durable context around that it will catch if you do that, but it's not 100% successful in catching it, so it's something to be aware of. Instead, what you do is, if you need to break something off, like you need to run an HTTP request, then you break that off into another function, and you just call that from here.
Right.
So I think that was kind of like the basics that I wanted to cover around durable functions. Is there anything that you wanted to add to it?
One thing, you might have said it, talk about, maybe scroll down to pattern number 2, was it?
Number 2.
Fan out, fan in. Maybe it kind of goes along with the human interaction part as well, but another part is, like, I guess, how long, for a durable function, how long does it stay alive? You know, like, say you're waiting on some sort of human interaction for that, does it, what happens after 5 or 10 minutes? With a normal Azure function, you're waiting, it's going to die, and then that process is lost. But with a durable function, how does that work, right?
Right.
It's going to stay alive.
Right. So, yeah, so that's a great point that I totally missed. Thank you for pointing that out. So even if these things in here take a really long time to execute, this function doesn't remain active during that time. Right. So your orchestration process can take days or weeks or months or years or however long you want, and you're not going to be billed for that time the execution is happening. You're only going to be billed for time that functions are being called. So if you call like F1 and returns really quickly, and all of these things return really quickly, then you're only going to be billed for the time basically that these functions are called, plus a tiny little bit of extra time and execution ticks for running this function, whatever it was, 4 times.
Right, because that's just the one that's doing the orchestration, doing the coordinating. So it's a very little processing time in there, little logic, but the real like where you're gonna spend the money is gonna be in the actual Azure functions doing the processing like normal.
Yeah, that's right. So maybe a even better example of this is this like fan out thing. Yeah, so if you kick this off and it fans out maybe 20 services, and 19 of those return really quickly, and there's just one that happens to take extra time, so one of them takes 10 minutes to run, then you're only going to be billed for that 10-minute thing once. It's only going to be this like one
right.
10-minute function that's going to be the big bill, and everything else is going to be fairly small.
Right.
Yeah.
Cool. Yeah, and I think you also mentioned it, the ability to use the Azure Signal R service with these durable functions and being able to set that up. I think that's going to be a very cool thing to see happen. To have you can host an Angular, static Angular site, and then have the durable functions and actually have Signal R running for it without having any servers, anything going on. So
yeah. So I always felt like this was like the one missing piece in the serverless puzzle of
agreed.
Azure, that you could host your website in blob storage, and then you front it with a CDN, and that does your SSL termination, and you do your database operations using functions, and that talks to a Cosmos database maybe, which is entirely serverless. But then always the bit was like, hey, when I click this and it goes off and it runs in the background for 30 seconds, and I want to tell people immediately when it's finished, how do I do that? And at the moment, the only answer was you got a poll. But with Signal R service, then you can actually push that information straight back to them, and you don't have to worry about setting up servers or anything for that. So we're there. We've achieved serverless.
Woohoo!
Yeah. All right. Great. So we had something planned for our next one, but I've totally forgotten what it was already. I think we were going to delve into some of these patterns a little bit more and build some example applications around them.
Yeah, I'm looking it up now. I think one of them was going to be the first one we have on our list is chaining. So maybe we'll put something together for the first pattern there in this doc and go through an example a little bit more in detail and explain it all the way through.
Yeah, I'm looking forward to that. I'm going to spend between now and whenever we record that trying to come up with some sort of chain rule joke.
Oh gosh, it might be difficult.
Yeah, a little bit of calculus humor for you there, everyone. Okay, we'll see everybody on the next episode. Thanks for tuning in.
Bye, everyone.